Hey guys, the objective of this video is to find the vertical stress increase under an arbitrary shape using Newmark's chart. So we've been given this shape here. It's a triangle. It's an equilateral triangle where all sides are 8 meters. We're concerned about the stress under a point A, which is in the corner here. The depth we're looking at is 6 meters and the pressure applied is 100 kPa. So the way we find this is using this formula that the change in stress is equal to N, which we're going to see what that is in a sec, times the influence factor, which we're going to see in a sec as well, times the surface pressure. Now the first thing we've got to do is go to our Newmark's chart. It looks like this. And we're literally going to come and draw on our shape, and at the center we're going to put the point we're interested in. So that's going to be point A. But before we do this, we have to determine a scale for our diagram. And the way we determine a scale is by looking at the scale given here, AB. Now, we're concerned at a depth of 6 meters. So we go ahead and call AB 6 meters, which I've done before. And now we can measure that 6 meters in our diagram is the same as 3 centimeters. So from my rule, I can see that that's 3 centimeters. So 6 meters equals 3 centimeters, which means 1 centimeter equals 2 meters, right? So we're going to come and scale our drawing on here, putting the point we're interested in, so point A, at the center of this diagram, and then we're literally going to count the number of these rectangles inside our shape, which is N. We're then going to times that by a given influence factor. So for our diagram, the influence factor is 0.005, and then times that by the surface pressure. So let's go ahead and draw our diagram. We have a scale of 1 centimeter equals 2 meters, and we want to put the point we're interested in, so point A, at the center. So here's point A. Once again, we can draw this off in any direction. It doesn't matter because it's radial. It goes out, so it doesn't matter which direction we draw it in. So I'm just going to draw it in this quadrant here. So it's 8 meters. So 1 centimeter equals 2 meters, which means 4 centimeter equals 8 meters. So we're going to come out to 4. Now I'm going to do this with a protractor to be a little bit more precise. So we have an equilateral triangle. So we come out at 60 degrees, which is up there. So something like this, and at 60 degrees, which is like this, and these two sides should equal 4 centimeters, which they do. Okay, so we've drawn a triangle on our Newmark's chart with, once again, the point we're interested in, point A, being put at the center. Say we're interested in the point perfectly in the center of this triangle, we would draw our triangle such that the center of the triangle is at the center of the Newmark's chart. So that is just where the point we're interested in. Now all we do is literally count the number of these curvilinear rectangles, whatever you want to call them. You have to be quite approximate. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So we have 21 so far. Let's call this 1, 2. Let's just call that, let's say all this makes up 1. So that's 22. And let's say 1, 2, that makes up 1. So 23. Let's say that makes, and all the rest make up 1. So 24. Once again, it's a very approximate solution. So we have an N of 24. So our change in stress would be 24 times by the influence factor, which is given on the diagram of 0.005. So times 0.005 times by the surface pressure of 100 kPa. And if we were to go ahead and work this out, 0.05 times 100, we would get a vertical stress increase of 12 kPa. Okay, so Newmark's method is not hard. It's a bit non-precise, but it is definitely a way of doing it. You can do this for any shape. I mean, you could do it for a circle like we've done before. You could do it for a rectangle. So if you're ever stuck, I'd recommend using Newmark's chart. But the other methods for circle and rectangle would definitely be used over this. This is only for arbitrary shapes, and it's not too hard. Once again, all you have to do is be given a depth. You use that depth to scale off. You then use that scale to draw your shape, where the center of the Newmark's chart is the point you're interested in. You then count the number of curvilinear rectangles, so we've got 24. You multiply that by the influence factor, which is given here, and then you multiply that by the surface pressure, which will be given. Anyway guys, in the next video I'm going to go and do a comprehensive example where we look at the vertical stress increase due to a foundation, and we're going to go ahead and find the total settlement. So I definitely recommend you look at the next video. Hope that helps, guys.